Number 2, complete a table of values, then graph each function. So it's important to realize that there are two functions here. One of our functions is 2, and to draw 2, that is a horizontal line at 2, just like this. Okay, anytime you see like y equals something, and it's just a number, that's a horizontal line at that location. But it then gives us this extra piece. It says only graph it when x is less than or equal to 1. So if I go up at 1 and I think about where that is, that's here and then to the left. Okay, that's where I'm trying to graph. So that means that this part over here to the right of 1 I don't want. So I'm going to get rid of it. I'm only going to graph the line y equals 2 from 1 to the left. Okay, because it's just a piece of our graph. This is a piecewise graph, so that's the first piece of our graph, is y equals 2 when x is less than or equal to 1. And we could put a table of values for that if we had, say, -1, 0, and 1. If you plug those in, there's nothing to plug into, so they give you all 2's. And then we would use another table of values for our next part. Starting with 1, I want to plug in numbers that are bigger than 1. And you might say, well, why do I have to plug in 1 if it's greater than? It's not equal to, so I shouldn't have to plug it in, right? Well, what we're going to do is we're going to put an open dot at 1 to show that it's not equal to. So that means we still have to plug it in. So to do that, we do 3 times 1, and we get 3. We do 3 times 2, and get 6. 3 times 3, and get 9. And so remember that 1 comma 3 is an open dot because we're not equal to. And then we keep going. 2, 6, 3, 9. And then we draw that line going up and to the right. So that's that question. Number 3. Sketch the solution to each system of inequalities. So we've got x is less than or equal to 4. Remember, to draw that line, you go to 4 on the x-axis and you draw a vertical line. It will be a solid line because it's equal to at 4, less than or equal to. So solid line because of the line underneath. To the left of 4, is where we're going to shade, because that's all of the numbers that are less than 4. So we're going to shade to the left of this line we have drawn. Then we draw y is greater than -5, so go to -5 on your y-axis, and then you're going to do a not solid line, so a dashed or a dotted line, because y is greater than -5, but it's not equal to. Okay, since it's greater, that means we want to shade above, because where are the numbers that are bigger than -5? They're up here, like 6. 6 is bigger than -5, so we want to shade above the green line to the left of the blue line, which means that our answer region is this right here. All of this. And if you have to shade, one of them and then shade the other and then shade this most darkly or erase the rest of it, then that's fine. But this is our answer region. Number 4, solve each system by elimination. So when we look for elimination, we want to say, okay, is there a way I can get the same number in front of either both x's or both y's? We've already got the same number in front of both y's here. That's good. But we also want them to be different signs. So we're going to take one of these equations, and it doesn't matter which one. We're going to multiply by -1 so that we can change it to a positive 3y. But make sure that you change everything in that equation. And then I'll rewrite the first one underneath so that we can continue our work. Now, if we add our equations together, 3y minus 3y will cancel each other out. -x plus -2x is -3x. -18 plus -9 is -27. All we've got to do now is divide by -3 on both sides, and that gives you 9. If this is multiple choice and you only have one x value that's 9, you'd be able to pick it, but we do need to go ahead and plug back in for y in this case. So pick either equation. I'm going to pick the first one. Negative 2 times 9 minus 3y equals negative 9. Multiply this right here. Negative 18 minus 3y equals negative 9. Add 18 over. Negative 3y equals 9. Divide both sides by negative 3. And you get negative 3. Now, it was very important for us to do all of this right, because we could have very easily gotten at the end here a positive 3 because we weren't paying attention to our negatives. But the correct answer here on our multiple choice is 9 comma negative 3. So that's that. Moving on, 5 and 6 are similar problems. We're trying to graph a quadratic equation, which is a parabola, and we're supposed to have a vertex, an axis of symmetry, and a table of values. So how we find our vertex depends on the kind of problem. If there's no parentheses, then we label A is what's in front of x squared, B is what's in front of x, C is what's left over, and then we plug into the formula negative b over 2a. If you're having problems remembering this, but you do remember at least part of the quadratic formula song from back in the day, the one that goes pop goes the weasel, this is the beginning and the end of that song, because you start off and you go x equals negative b, and then at the end you go all over 2a. So just remember the beginning and end, and you've got this formula memorized. So let's plug that in. Let's plug these values in. B is 6. So on top I have negative 6. On the bottom I have A, which is negative 1. And work this out. This is negative 6 over negative 2, which is positive 3. So what we do is we put that in the middle of our table of values, because that is the turning point in our graph. It's either the lowest or the highest point. So once I have it in the middle, I pick things above, like 2 and 1. Well, I guess above would be 4 and 5, and things below 2 and 1. But I pick numbers around 3, and then I plug them into my function up here. And so I would do like negative 1 squared plus 6 times 1 minus 5. And I'd plug that in, and I would see what I get for my answer. So that gives me 0. And then I would plug in 2, and so on. Another thing you can do is you can actually put this in on y equals and go to second graph, and you can get a table of values that way. This would be 3. Then you plug in 3 and work it out, and you should get 4. You should plug in 4, work it out, and you get 3. Plug in 5, work it out, and you should get 0. And this should always happen, that the numbers closest to your vertex, 2 and 4, they gave us the same answer. The numbers farther away, 1 and 5, they gave us the same answer. That's how we get this nifty symmetry for our parabola. So plot your points. And draw your parabola. And there we go. Now it asked us to say what our vertex was. Our vertex is that point at the top, 3, 4. Our axis of symmetry, think about where is the line that splits this in half. It would be this line right here, which goes through 3. So our axis of symmetry is x equals 3. Number 6 looks a little different, because instead of being in standard form, now we're in vertex form. So here's how we deal with this. The vertex is staring us in the face. You take what's in with x, and you make it opposite of what it is, and that gives you the x value of your vertex. You take what's on the outside, -1, and that is your y value. So our vertex, if we know what we're doing, we know right away is -2, -1. So we're ready for our table of values, and that goes in the middle. We pick numbers close to -2, and we plug them into our formula up here. So you would do like 2 times 0 plus 2 squared minus 1, and you would work that out and get 7. And then you'd go back in and you'd plug in -1, and you'd get 1, and then you should get 1 and 7 again. So then plot these points, and your graph should fit on the graph that's provided. That's a really good sign you did something wrong, like maybe your vertex is the wrong sign or something, as if you're getting values that won't fit on your graph. Okay, so there is my graph, and I just need to say the axis of symmetry is this line that goes through -2. Number 7, explain where the solutions of a quadratic equation are found, then state the solutions. They give us the graph, so we don't even have to do anything except look for our solutions, which are happening when x is -3 and when x is +6. So those are our solutions. How do we say where those occur? Well, it happened where the graph went through our x-axis. So that's what we would say, that our solutions are where the graph crosses the x-axis. On number 8 and number 9, we need to use our graphing calculator to find some zeros. So remember, you plug into y equals x squared minus 4x minus 1, and you go to second trace, and you pick the option that says 0, and it'll ask you for your left bound, your right bound, and then to guess, and what you should get are a couple of decimals. So on 8, if you do that, you should get -0.2 and 4.2. It does ask us to round to the nearest tenth, so that's 1 decimal place. And then when you plug in the second one, number 9, and you plug in your function to y equals, and then you do second trace 0, tell it the left bound, the right bound, and guess, you should get -3.6, -0.4. Make sure that if you can't get those answers, that you can look up how to do them on a video I posted on Edmodo last week whenever we went over this the first time in class, or make sure you get with your teacher before class time tomorrow when you're supposed to be taking your test. Don't go up to them during class and ask, or they might get mad at you or something, because that's a little late to go up and ask. Okay, solve the quadratic equation. We want to factor on 10 through 12 and then set our different parentheses equal to 0 so we can solve. So on number 10, it's not what I wanted to do. On number 10, I'm going to use slide and divide. That's personally how I like to factor things like that. And so to do that, you take the first number and you slide it to the last number. And we're ignoring for now that this says equals 0. We'll bring that back in later. So I slide the 3, and this becomes x squared minus 10x minus 24, because when we slide, we're going to multiply 3 times -8. And we do that because now I can factor this into two parentheses using those rules that say that this has to split up here and here, and our 24, that's got to go here and here. But we've got to do that in such a way that we are multiplying to get negative 24 and adding, or you could think of it like subtracting to get negative 10. So you might be tempted to use 4 and 6, but we'd have to make both of those negative, and that wouldn't give us negative 24. So instead, we want to use negative 12 and positive 2. But we're not done. We did the slide part up above. Now we got to do the divide part. Okay, we slid, now we've got to divide. So I'm going to divide by that number I slid earlier, and that gives me x minus 4. And if you can't divide, like this one divided fine, but this one you can't divide, so you take the number and move it in front of your x. If you can simplify, simplify first. If it's like, if this had been 4/6, I can simplify that, so I'd want to do that. But if it doesn't get rid of your fraction, move the bottom number over. And it equals 0 because we are actually trying to figure out what is x. So we set each part equal to 0. We solve, so here we would add 4 to both sides and get x equals 4. Here we would subtract 2 and say 3x equals negative 2. So, and then divide by 3, which means x equals negative 2/3. So there's our two answers, x equals 4 and x equals negative 2/3. 11. So anytime you see two terms, and actually on all of these, we're supposed to be checking to see, is there something I can take out of both initially? There's nothing I can take out of n squared and 36. There's two terms, which means I have to be able to split this up in such a way that this first thing in each multiplies together to get n squared. Well, the only way to do that is to use n and n. So n and n. The second part of our parentheses is going to come from how can I get 36 if I'm trying to multiply together. And I have to do it in such a way that I have the same number both times. So what times what gives me 36? 6 and 6. Then we make one of them a plus sign and one of them a minus sign. Okay, because that's how we get negative 36. It's also how, if we FOILed this back out to check ourselves, we would end up canceling out our n term. That would have been here in the middle, the 0 n term. So set each part of this equal to 0 so that we can figure out what n is. You'll have to subtract 6 on the first one and add 6 on the second one. So n is positive 6 and negative 6. And finally, in this section, this is where we look at this and we say, wait a second, there's an m that they both have in common. So I am going to take out the m. When I take an m from m squared, I still have m. When I take the m out of 8m, I'm left with 8. Don't think of it like taking out as in like subtracting. I'm not left with 7m. I'm saying I have an 8 and an m, and I'm just going to take that m away. Like, I'm going to take it completely out. And so I'm just left with 8. Now take each part of this and set it equal to 0. And solve if needed. M equals negative 8 and 0. Word problems. Okay, on this first one, a manufacturer of lighting fixtures has daily production costs of C of x equals 8 minus x plus 0.25x squared, where C is the total cost in dollars and x is the number of units produced. Determine how many fixtures should be produced each day to yield a minimum cost. Now, when we talk about having a parabola and having a vertex, our vertex is either going to give us a minimum or a maximum, depending on what kind of an equation it is. And so what's happening here is this equation is giving us a minimum because it's a parabola opening up. Now, this right here is not how we normally see this type of equation. We normally see it in standard form, which means put your x squared first, and then put x, and then put your number. Because all we really want when we look for the minimum is to find the vertex, which is remember, negative b over 2a. So to do that, I have to know what a is. It's the number in front of x squared. B is the number in front of x, and c is the number left over. So I do negative b over 2 times a. Well, a negative negative turns positive. 2 times 0.25 is 0.5. And when you look at this, don't be like, I don't know what that is. Just put it on your calculator. 1 divided by 0.5 gives you 2. So, if I think back to my problem, x was the number of fixtures that we produce. So we're saying you need to produce 2 fixtures. Then we take this 2 and we plug it back into our formula at the top, because they also want to know how much our cost is. And that's what c of x, that's what our y value is telling us, is how much it costs to make this. So if you type this into your calculator or whatever, it gives you 7, and that is a money amount, so that's $7. These next two are pretty easy once you realize they gave us like all the information we need. They give us this formula here at the end that has v of 0 in it, and then up here they tell us the initial velocity is 112. Guess what? V stands for not just victory, but velocity. So h of t equals 112 t minus 16 t squared. Plug that into your calculator, and when you do, we're going to plug it into y equals, and instead of putting in t's, we're going to type in x's. When you first plug it in, depending on your window, it may not look like much. It may show you, that was terrible, let me try that again. It may show you, that's not much better. Basically just like a line over here, and you're like, that's supposed to be a parabola, what's going on? Go to your window, and go to your y max, and make that bigger. Make it something like 150 or more, okay? Like play around with that number. Now, I picked 150 because if I have 112 here, I may need something bigger than 112. But eventually, depending on what you pick, your graph should end up looking like a parabola. And what we're trying to find is this value right here using second trace and then 0, and it asks us for our left bound and our right bound and all of that jazz. Okay, and if you do that, it gives us an awesome answer. It gives us 7, which means that the ball hits the ground 7 seconds after the softball player hits it. So that's cool. 15. So now they have h naught in our formula, and they tell us we're on a building 576 feet tall. So plug that in. H of t equals negative 16t squared plus 576. Okay, plug it in. Remember that to change your t squared to an x. And this time, when I change my y max underneath window, I might want to pick something big like 600 in order to see my whole parabola, because this time it's going to look like this once you've got it in there with a good window. And I want to find the point on the right side. I don't want a negative value for my x, because it's not going to take negative seconds to fall off the roof. I want to find this one over here. So you do second trace, 0, left bound, right bound, guess, and it will tell you your answer is 6 seconds. Now all that's left here for us is factoring. So when it says factor each completely, we do want to go through and look and say, is there something I can factor out first? Like, do they have a number in common? Do they have a variable in common? On 16 they don't. We have two terms, so we're trying to split this up into two different things. So 16x squared splits up into 4x and 4x. Y squared is going to split up into y and y, which means that we'll have 4x plus y and 4x minus y. Okay, because the front of your parentheses is what you're going to do to multiply to get 16x squared. The end of your parentheses is what you've got to do to multiply and get negative y squared. So that's our answer. And keep in mind, none of these say equal 0, so we're not trying to set any parentheses equal to 0 and solve. We've got three terms on 17. No numbers in common to take out at the beginning or letters or anything, so we're going to go straight to the good stuff and say, well, I've got to split n squared up into n and n, and then I need to figure out what multiplies to get negative 36 that will add to get 5. If you have problems doing that, list out some things first that multiply to get 36. And you can use your calculator to help you if you're not so good with the multiplication tables. Here are all of the things that multiply to get 36. I want negative 36, so I'm going to have to subtract my numbers to get 5, which means 4 and 9 are my winning pair. I want a positive 5, which means I need plus 9 and minus 5. Now on this one, you may be thinking slide and divide, but check and see. Can I divide all of these by 3? Why, yes I can. And go ahead and actually write out what it is if you divide them all by 3 before you try to factor again. Okay, because we can factor this parentheses now into two parentheses where we say, what do I multiply together to get 8? That will add to get negative 9. Make sure that you drop the 3 down as you're working. So what multiplies to get 8 that adds to get negative 9? That one's not so bad. It's negative 8 and negative 1. Make sure you don't forget that that's always a possibility to use, is the number itself and 1. 19. I cannot take out the 3, but I can take out, each of these have n squared inside of them that I can take out. So that would leave me with, I had 4 n's and I took out 2, so that's 3n squared. I can take out 2 of these and I'm left with 14n. And then I'm taking out all of the n squareds here, so that's minus 5. Now we have to slide and divide. So you take the 3 and you slide it over to the n. We're just going to let the n squared chill out here and come back for it later. Okay, so we've got n squared plus 14n minus 15. We want to factor that into two parentheses. So we're saying what multiplies to get negative 15, and it's going to subtract to get 14. So that's plus 15 and minus 1. But remember, we slid, so now we've got to divide by that 3 from the start. Okay, so if it divides evenly, I go ahead and do it. So that's n plus 5. This one doesn't, so I move the 3 in front. That's 3n minus 1. And now let's bring the n squared down and put it in front. Okay, because remember, our answer, we have to be able to, if we wanted to, go back through and multiply it out and get what we started with. And the only way to do that is with that n squared in front. Okay, number 20 is a straight up slide and divide. Okay, there's nothing in common I can take out, no variable in common. So slide that down, m squared plus 5m plus 6. I'm going to figure out what multiplies together to get 6. That will add to get 5. And so I put that in my parentheses. Multiplies to get 6, adds to get 5 should be 2 and 3. I slid. Now let me divide by 3. So the first parentheses will be 3m plus 2. The second one will just be m plus 1. Alright, 3 terms, but I've got more than one variable. They don't all have the same variable though, so I can't actually take out a variable. So what I've got to do is go to my 2 parentheses, and remember, the first thing in each parentheses is what multiplies to get this right here, m squared. So it's got to be m and m. The second part of each has to be what multiplies together to get negative 80n squared. Well, the n part of that means I'm going to have an n. Then I say, well, what multiplies to get negative 80 that will add to give me, or subtract in this case, to give me 2. And so that means we're going to use like plus 10 and minus 2. And so that n is there because we've got to have 10n times, why did I put 2 when I meant to put 8? Negative 8n. Now see how these will multiply together and give us that negative 80n squared. Alright. We've got 2 terms here, but we've got lots of things in common. We've got a 2 in common. They can both be divided by 2. They both have y squared we can take out. They both have an x we can take out. And it may help you to think about this like, now we're going to divide by what we took out. Okay, that's how we write what's left over, is by dividing by what we took out. So I took out the 2, I took out the y squared, I took out one of the x's, so it leaves me with an x. 4 divided by 2 is 2. And I still have a y but not an x. This here, since there's no squareds left, I can't factor again. I'm done. (23) looks like we've got a 5 in common and an x in common. So if I take a 5 and an x out of 5x squared, I'm left with an x. If I take a 5 and an x out here, I'm left with a y. And again, there's no squareds inside my parentheses, so I cannot factor that again. 24, I can divide both of these by 3, but I can't divide them both by a letter. They're different letters. So that gives me 9u squared minus 4v squared. And so this is where we go and we say, how can I split up 9u squared? It's got to be 3u and 3u. How can I split up 4v squared? 2v and 2v? 2v or not 2v? Anyway, and so I split it up, and the 9u squared splits up at the beginning. The 4v squared splits up at the end. One of them gets a plus, one of them gets a minus. So there's our answer. And finally, number 25. Have to slide and divide. So I slide the 5 down and I get 40. Because I multiply. I say, what do I multiply together to get 40? That adds to get negative 22. And I think for a bit and say, how about 20 and 2? So that'd be minus 20 minus 2. Divide, because we slid earlier, we've got to divide. So divide by 5. This divides evenly. And this does not. There's your review. Hope you had a great time watching me work it out.